Now let's look at some multi-step equations. Basically, we're going to continue solving for an unknown variable, but in these types of problems, we'll be doing a few things. Let's go ahead and start with some examples. First, we'll have 3x plus 4 minus 2x equals 9. Notice that in this case we have one variable, but you could see it two times. In fact, they are common or like terms. They have the same variable with the same exponent. In this case it would be 1. And so what we could do is, before we move numbers around or isolate the variable, let's combine like terms. When we say combine like terms, what that means is we are simplifying. So we're going to go ahead and put these terms together. I'm going to include the sign that goes before it and regroup them. 3x minus 2x plus 4 equals 9. Now 3x minus 2x is going to give us 1x. 1x, of course, is just x. So now we've broken it down, or we've combined it, condensed it, and it becomes x plus 4 equals 9. Now, when I talked in another video about solving for an unknown variable, we had an example similar to this setup. We want to use inverse operations. Inverse means opposite. Because this is addition, we want to use subtraction. So we're going to subtract the 4, and we're going to subtract on the other side. So we want to keep the balance, meaning we want to do the operation, whatever we do on one side, we have to do on the other side. So keep the balance. That's going to give us x equals 5. And the last thing I recommended in the previous video was to plug in your x value to check your work. So I'm going to go ahead and do that. I'm going to go all the way to here. I'll go ahead and rewrite it. And this is 3 times a number. So 3 times 5 plus 4 minus 2 times 5 equals 9. So everything on this left side needs to equal 9. And if it does, then I feel pretty confident that for this equation, x will be equal to 5. Now you might want to refer to order of operations when solving these types of equations. I'm going to go ahead and do multiplication first before I add and subtract. So I get 15 plus 4 minus 10 equals 9. Now that I only have addition and subtraction, I'm going to go left to right. So I'm starting with 15 and I'm adding 4. That gives me 19 minus 10 equals 9. And 19 minus 10 is going to give me 9, which equals 9. Because these two numbers are the same, the value of x, which is 5, works for this equation. Let's go ahead and do a couple more. Let's say we have negative 3 times the quantity of x minus 4. And that is going to equal 3x. So again, negative 3 times the quantity of x minus 4 equals 3x. In this case, because we have a number multiplied by a quantity within parentheses, we want to break up those parentheses or get rid of them. Instead of just throwing them out the window, we need to use distributive property. we're going to take negative 3 and multiply it to each part within the parentheses. So negative 3 times x is negative 3x. Negative 3 times negative 4 will give you a positive 12. And then that's going to be equal to 3x. Now in this problem, you'll see that the x value is on both sides. And our ultimate goal is to isolate the variable. That means we want it on one side of the equal sign. Because I don't have anything else attached to this x other than the 3, I'm going to move this 3 here over to the right side. And I'm going to do that by using inverse operations. This is a negative 3x, so the opposite or inverse would be a positive 3x. I'm going to do the same on the other side. So I'm keeping the balance. These two are going to cancel. I'm left with a positive 12, and 3 plus 3, or 3x plus 3x, will give me 6x. Now notice we have not figured out the value of x yet. So we're going to have to do another round of using an inverse operation, keeping the balance, and then likely we'll have an answer. Because this is multiplication 6 times a number, we want to do the opposite or inverse operation, and that means divide. So we're going to divide by this 6 so that they cancel, and I want to divide on the other side by 6. So x is 12 divided by 6, or 2. Now notice that in previous answers, the x was on the left-hand side, and then the value was on the right side. It really doesn't matter that in this case the x is on the right and the value is on the 2. If it makes you feel better, you could just rewrite it as x equals 2 instead of 2 equals x. Let's go ahead and check just to make sure. I'm going to plug in a 2 every time I see an x in this original equation. So negative 3 times the quantity of 2 minus 4 equals 3 times 2. I'm going to use order of operations and figure out what's inside the parentheses first before I multiply. 2 take away 4 is a negative 2. So I'm just rewriting. When I multiply two negatives together, I get a positive. So 3 times 2, or negative 3 times negative 2, is going to give you a positive 6. And 3 times 2 over here will also give you a 6. So this worked out. So the value for this equation for x, the value of x, is going to be 2. Let's do 2 more problems. In this case, we have 5x equals 240 plus 2x. Notice that I have x on both sides, similar to that last problem. I'm going to go ahead and subtract this 2x so that I move it over here, because there's no add or subtract associated with this 5x. So I'm going to do the opposite and do the same thing on the other side, keeping the balance. That's going to cancel, and I'm left with 240 on the right And 5x minus 2x will give me 3x. So 3x equals 240. But again, this is not just x equals 240. This is associated with a multiplication. It's a product. So again, we need to use inverse operations, keeping the balance, and then checking our work. The opposite of multiplication is division. So I want to divide by the 3 on both sides. That's going to cancel. I'm left with x equals 240 divided by 3 should give you 80. Now it's important to check your work. 5 times 80 equals 240 plus 2 times 80. 5 times 80 is going to give you 400. 240 plus 2 times 80 is 160. And we could do this on the side if you're not sure. It's 10. Should give you 400. So 400 is indeed equal to 400. So for this equation, the value of x is going to be 80. Now let's do one more example. Let's do a division problem. Let's say we have 48 divided by x, and that's going to equal 3. Because this is a division problem, we want to use the inverse of division, which is multiplication. And we're going to be multiplying whatever's in the denominator or the divisor of this division problem. So we're going to be multiplying by x to both sides. So I'm going to go ahead and rewrite that. We have x over 1 times 48 over x equals 3 times x. Now these x's can cancel, and we're left with 48 over 1, or just 48. Now we have 48 equals 3x, or 3 times x. Notice we don't have the value of x. In fact, we moved the x from the left side to the right side. But now we're not dealing with a division problem anymore. We're now dealing with a multiplication problem. So we're going to divide by 3 on both sides. That's going to cancel. We're left with x equals 16. And if I want to plug that into my original formula, I'm going to go 48 divided by 16, and that's going to give me 3. And if you're not sure, you can get out the calculator or do some mental math, but I know that's going to equal 3. So because 3 equals 3, the value of x in this equation is going to be 16.